Hello everyone. In this video, we are continue with the voltage gain calculation for this common source amplifier. So I explained the steps. First of all, we have to identify the topology. So here we can see. So this is the diagram A where we have to calculate the things. So this input is applied at the gate of M1 and output is taken from its drain. So I can say this is the common source topology. The first thing we have to identify the topology. It is common source topology. And now, second thing is we have to calculate the impedance at different nodes. So if you want to calculate the impedance, so this M2, okay, impedance calculation, impedance calculations. And the third thing is simply apply the small signal or gain expression, small signal or gain expressions. For this M2, if we are looking from its drain, from source, yeah, here it was basically the bias voltage, which is now zero because we make it zero for AC analysis. This DC voltage is zero. So this the impedance from the source of M2 is nothing but 1 upon GM2 that I explained in the previous video also. In this case, lambda 2 is zero. And if lambda 2 is not equal to 0, in that case, I also explained this thing. The R from the source of this M2, R source from the M2 is 1 upon GM2 plus 1 upon R02 if lambda is not equal to 0. For here, simplicity lambda is 0, so 1 upon GM2. And yeah, this VDD is 0 for the AC analysis. And now this picture is completely visible. Now you can see that now if you draw the small signal, here, I can also calculate it without drawing the small signal. But here for the starting, the small signal is important. So is your V in and output is taken from the drain. So this thing is GM1, GM1, VGS1, and lambda is 0. So only RD is there. Only RD is there. And we are taking output at this RD. Okay. We are taking the output as RD. So this is your VGS1. And this impedance is nothing but 1 upon GM2. Okay. So, yes. So this is your ID1, which is going to flow across this 1 upon GM2 also. This is your ID1. Okay. So I'm changing the color. So if I want to calculate the expression for the output, if this ID is entering into this drain, is the drain of M, this is the drain of M1. So this ID is entering into this. And so for this RD, the ID1 is flowing outside. So the expression for V out is minus ID1 cross RD. So this is your first equation. And second equation we'll get from this input KVL. So this input KVL is V in minus VGS1 minus ID1 times 1 upon GM2 equal to 0. From the second equation, yeah, okay. From this second equation, we can compute ID1 equal to V in minus VGS1 times GM2. So yeah, this is your second equation. Now we need one more equation because we have to relate. Now we have to relate this VGS1 either with ID1 or with any of V out or V in. Okay, this is the ID1 equal to this and V out this. So the third equation that we are missing here, yeah, this equation is nothing but, yeah, third equation is this. So ID1 is also equal to GM1 VGS1. This is directly from this drain current. So this is the ID1 actually. This is not properly written. So here we can replace this your VGS1 equal to ID1 by GM1. So put this thing inside this. So put this VGS1 in this equation and we'll get the expression in terms of ID1. So we'll get the terms of ID1, and whatever we get the ID1 from here, we put inside this first equation. What I will get the value of ID1 from here, we'll put in this first equation. So we'll get the expression for voltage gain here. If I exactly calculate it, then yeah, this ID, okay, VSG on this. So this ID1, I'm writing it here. ID1 is equal to V in minus ID1 by GM1 times GM2. So this is, if we take the ID on one side, then it will give you like, we take the ID1 common. So it is going to be one, sorry, it is going to be, so it is going to be 1 plus, wait, yeah, it is going to be 1 plus GM2 by GM1, and yeah, it is equal to V in GM2. So this is your ID. So from here, the ID1 is GM1, GM2, V in divided by GM1 plus GM2. This is your ID1. Now put this thing in expression of 1. So this is a V out. So this V out is minus ID1 to RD. So if we put ID1 here, we have minus GM1, GM2 divided by GM1 plus GM2 multiplied with Vn and Rd. Okay. So this Vn will go down and we will have the voltage gain expression, and we will have the voltage gain expression V out GM1 plus GM2. So this is the complete expression for voltage gain. So what were the approximation and consideration here? The lambda was 0. And if lambda is not equal to 0, this expression will change. It will not be 1 upon GM2. It will be some additional term of 1 upon GM2 plus 1 upon R0 over 2. And if lambda is also considered for first transistor, we will have the additional term here. Then in that case, we will have this additional term here also. That will be your R0 1. So the complexity will little bit increase, but you can simply apply these KVL and KCL carefully. You will get the expression for the voltage gain. So I think this is enough for this video. In next video, we will deal with the other concept or either the questions. So yeah, thank you.